All right, so here to help out with writing and solving proportions. Let me scroll up here. So you'll be working on this worksheet at some point in this week, whether it's the 17th or the 18th or the 19th, while I am gone, because I will be out on the Big Money Expedition the 17th, 18th, and 19th. That's Monday, Tuesday, and Wednesday. Some of you might be with me, so you might not see this until on Thursday, in which you'll be working on this worksheet then. But again, if you're not on expedition, you will be working on this either Tuesday or Wednesday. And so this is me trying to help out, just to make sure that you understand what a proportion is and how we can solve them. There are multiple ways, and some of you have already been solving proportions, whether you've known it or not, and it's because some of you have got to the IXLs of solving proportions. But there are multiple ways that we can solve them. So I want to talk about that and help out with, especially writing, because that can be a little bit more challenging than the solving piece. So again, I'm going to go through a couple things here. So make sure that you, again, you remember this. You can take down notes, but you'll be working on this worksheet in class. So here's a gimme. Okay, when you create two blank ratios, it is called a blank. Okay, so it is when you create two equivalent ratios, it is called a proportion. Okay, so we've been working with rates. We've been talking about ratios. We've been talking about unit rates. Okay, they all fall under the same umbrella of ratios. But when you have two equivalent ratios, it forms a proportion. We've talked about that before with the equivalent ratios, like that I have listed here, in which you have to find an equivalent ratio to that. It will form a proportion. And so, looking at an example of solving a proportion, I have one right here. So here's an example. Okay, I have 3 over x, or 3 compared to x, is equal to 12 to 16. So we got to figure out what x is. So this is just like solving an equation. So just like solving an equation, I'm looking for what is the value of x. So I give some pretty detailed steps here, so make sure that you look at these. But this is mainly focused on using cross products and cross multiplication, something that not many of you have done yet because it's not something that you're aware about yet. So I'm trying to help you out with that in this video. Many of you, just kind of our conversations of ratios and equivalent ratios, know that I could multiply 3 by 4 to get 12. So multiply by 4 to get 12, that means I can multiply x by 4 to get 16. So that lets me know that x would be equal to 4. Now, that's with that, and I could do that the same with 12 and 16. So I know I could say 16 divided by 12, oops, wrong button, sorry. 16 divided by 12 is 1 1/3. So if I multiply 3 by 1 1/3, I will get 4. So again, what I had said here is 12 multiplied by 1 1/3. Can't write that small. And then 3 multiplied by 1 1/3. Doesn't look like a third, sorry, but it is 1 1/3. So there's all the different connections that we can have that you should hopefully have some idea of from what we've already talked about. Now, both these scenarios, x is equal to 4 every single time. And checking that, I talk about that kind of here as well, of making sure, okay, 12 times 4 and 3 times 6. I'll get to that in a bit. But you can also say, all right, what is 3 divided by 4? To find the decimal version, it's 0.75. Okay, let's check 12 over 16, or 12 to 16. So 12 divided by 16 is 0.75. So I get the same exact decimal value. Therefore, I know that I am correct and that these two ratios are equivalent. So that is kind of the thing that you've used so far. But using cross multiplication, we can look at the proportion and make sure that, okay, you know what numbers you're multiplying by one another and where your variable is at. So you're going to multiply diagonal. So that's why it's called cross multiplication and cross products. So 3 multiplied by 16, okay, on one side, doesn't matter which side, is going to be equal to 48. 12 multiplied by x is just 12x. At this point, it's just solving a one-step equation. So the opposite of multiplying by 12 would be to divide by 12. So I divide both sides by 12, and I get x, again, is equal to 4. So the steps really in a simplified manner are just saying cross multiply, then divide by whatever number is diagonal from x. All right, and again, Here, I know that x equal to 4, and I can see that 3/4 or 3/4 is equivalent to 12 to 16. So you have quite a few practice problems then down below here to practice on. It doesn't matter if there's just numbers and variables or if you have actual labels here, but make sure with the labels you're paying attention to. Notice this is pieces and pieces in the bottom part of the ratios. Dollar amount, D, dollar amount. For then the 4 packs, I know that Y is going to be a certain number of packs. So if I jump down here to looking at an example, okay, I can say, all right, and again, you could do a number of different ways. And I can say, okay, what am I multiplying 16 by to get 12, or 12 to get 16? But a number of different ways. But if I just look diagonal here, 16 cats is diagonal to 6, or 16 cats is diagonal to Y. So 16, just got to turn my pen back on. 16 multiplied by Y is 16Y. 12 dogs multiplied by 12 cats. So the 12, again, we're multiplying diagonal, so cross products. So product means the answer to a multiplication problem. So 12 times 12 is 144. So then I'm going to solve this, okay, by solving for Y, and the opposite of multiplying by 16 would be to divide by 16. So I cross multiplied, and now I'm dividing by what is with Y. So Y will be equal to 9, and I can label this because I know that, okay, cats were on top, dogs are going to be on bottom, so that's going to be 9 dogs for my answer there. Okay, so there is an example of solving using cross multiplication. Okay, there are many other ways that you could use as well. You don't have to use cross multiplication, but cross multiplication always works. Sometimes trying to think, okay, 16 multiplied by what will get you 12? You end up with some repeating decimals and some hard to work with fractions. And so cross multiplying and then dividing is just kind of a method that's going to work with whatever scenario, whatever ratios that you're looking at in your proportion. If we then scroll back up, the other part of this is writing proportions. So I also give some pretty detailed instructions here, so make sure that you read through those thoroughly here, again, even after I go through this. So step 1 is you're trying to identify the full rate. So you're going to be given a rate in this problem. Okay, it's not going to be a unit rate, because you can see in this first problem, it says $35 for 5 hours of work. That right there is a rate. It's saying $35 per every 5 hours that Haley works. Okay, then part B, this next step would be find what additional information that you have. Okay, so you're going to write this in an appropriate place with the new rate. So I'll talk about that in a bit here too. And then you're trying to figure out what information you're missing. So what are you being asked to find? So an example of B and C kind of put together. The second sentence says, how much would she earn for working 7 hours? Okay, B, the additional information I know is that she worked 7 total hours. What am I trying to find for C? Well, I'm trying to find how much she earned. And then D is in this actually, okay, solving, okay, using the rates that we have to solve the proportion. So again, I have kind of a setup here for you to have a kind of a good structure to write a proportion. I'm going to show you one here without as much. And so in the word problem here on A, I have Joel used 9 centimeters of tape to wrap 3 presents. How much tape will Joel need in all if he has to wrap 5 presents? Assume the relationship is directly proportional. So what that means is that this is a proportional relationship. We're assuming that for every 3 presents that he's going to wrap, he's going to use 9 centimeters. That's what this last sentence means. So again, writing my rate that I know, okay, doesn't matter necessarily where I put 9 centimeters and where I put 3 presents. Okay, if you want to put centimeters on top, you may. If you want to put presents on top, you may do that as well. I'm going to put presents on top because presents never mind. I'm going to back it up. I'm going to put centimeters on top. Sorry. So 9 centimeters per 3 presents. So that's a rate right there because I'm saying basically how many centimeters is he using per present. So I could define the unit rate. You don't need to find the unit rate because we're solving a proportion, but you could find the unit rate and then go from there to solve this. And again, one of the many different ways you could solve proportions. So I have 9 centimeters per every 3 presents. Okay, then the additional information that I'm given is that he has to wrap 5 presents. So I said earlier that you have to make sure you know where to put this additional information. So it's wrapping 5 presents. So it's important to label here because it's easy to determine, okay, I have presents on the bottom and centimeters on top. The presents will go with presents. So I'm going to put 5 presents. Oops, if I can spell presents on the bottom. Okay, then what I don't know, which was part C, step C, I should say. Okay, that is my variable. You can say whatever, use whatever variable you want. You can use X every single time. You could use C for centimeters. Doesn't matter. So again, here I'm looking at solving this proportion. So again, you can find the unit rate and then use that. Or we could think, let me change colors here. We could think a number of different things. I could think, okay, 9. Let's go this way instead, actually. Because I don't think it would be from the bottom to the top. It can be. Okay, but I can think, okay, 3 multiplied by 3 will get me 9. So if I multiply 5 by 3, it'll get me this answer as well. Or sorry, 5 multiplied by 3. I can't remember what I just said, but you're multiplying 5 by 3 because that's what I did to the bottom to get the top on the other ratio. So I already know that, get out of here. So I already know that my answer is going to be 15 centimeters. Okay, I can also, again, use proportional, or I can use cross multiplying. So again, I'm looking at 9 and 5 and 3 and C. Hopefully I didn't cover too much of that up. So 3 multiplied by C is going to be 3C. 9 multiplied by 5 is going to be 45. Then I want to solve by doing the opposite of what multiplying by 3 would be. So the opposite of multiplying by 3 would be to divide. So I'm going to be dividing both sides by 3. And when I do 45 divided by, I get C on the left side, but 45 divided by 3 is going to give me 15 again. Again, I know I can label because if I'm looking just to the label to the left, this is centimeters. That means that the top of this ratio is also going to be centimeters. So either way, you get the same exact answer. Both are completely correct thinking. So if you have questions, please ask this up, but also you can send me an email, but also I will be back in class and helping you out with any questions that you have. But good luck, and again, I will see you soon.